Hello and welcome all my grade 11 advanced students to today's video. We are starting finally with the math revision for your grade with this video on end of term for exam for term 3. This video has some important questions for your exam coverage on the lesson 9.7, the binomial theorem. So in today's video, from your exam coverage that has come, we are going to be covering part 3, learning objective 23, examples 1 to 3. So a very important and must watch video for all of you. Stay glued to the video till the end and let me know any questions or comments that you have in the chat box. So welcome to today's session. In today's session for grade 11 advanced, we are going to cover from chapter 9 sequences and series, lesson 9.7, the binomial theorem. Before we proceed with the video, I would request you to watch my previous two videos which I have made for Pascal's triangle and binomial theorem. I will put the link in the description box so that you can watch them before you proceed and see what questions are we solving in this video. So our learning objective in today's video will be the following. First, we are going to use the Pascal's triangle to expand powers of binomials, and next we are going to use the binomial theorem to expand power of binomials. So let's get started with the video and see what we are learning today. So our main motive of making this video would be to solve the questions on learning objective 23. As you see, I have put this slide from your exam coverage. Our learning objective is to use the binomial theorem to expand the power of binomials. So we are going to be solving questions from these two examples 1 to 3, which are on your book on page 595 and 596. So let's get started with the video and first understand the concept of binomial theorem and Pascal's triangle and then solve these questions on it. Understand the key concept of binomial theorem. So I have given you here the concept summary. So always remember these points when you are solving a question or expanding a binomial using the binomial theorem. So here in the binomial expansion of a plus b to the power n, so remember it's a binomial because it has two terms and it is raised to the power n. So when you have such a binomial a plus b whole to the power n and you have to expand it using binomial theorem, there are going to be n plus 1 terms. So if you expand, if n is say 5, then the number of terms in the expansion are going to be 1 more than that. So it's going to be 6. N is the exponent of a in the first term and b in the last term. So that means this expansion starts with a to the power n and ends at b to the power n. As we proceed in the expansion in successive terms, the power of a will keep on decreasing by 1 and the power of b will keep on increasing by 1. Make sure that always for each term the sum of the exponents. So when you add the two powers, it is still coming to be n. This is a way to check. And as you will see when we solve the questions, the coefficients are going to be symmetric. So there will be same binomial coefficient coming for some of the terms. And what are those terms? We are now going to see when we solve a question. Now I give to you the concept of Pascal's triangle. We can use the Pascal triangle to expand the power of binomials. This triangle was named after a French mathematician Blaise Pascal, and it has a special way of writing the coefficients of a binomial expansion. So this triangular way of writing the numbers represents a Pascal triangle because as you can see, they are in the shape of a triangle. So if I try to draw a boundary here, I'm doing a rough boundary, it will resemble the shape of a triangle. That's why this name Pascal's triangle, right? And there are some special patterns that you observe in this Pascal triangle. One is that the corners have 1 every time. Okay, and the first row is called generally the 0th row, which represents the binomial coefficient of a plus b to the power 0. So if the power is 0, this one is the 0th row. Then you have a plus b to the power 1. This is the first row. And always remember the power and the row number are same. So if the power is 1, this is first row. If the power is 2, it is going to be the second row. If the power is 3, it is going to be the third row and so on. So for this expansion, you can calculate the binomial coefficients by the numbers that are there in the Pascal triangle. Okay, that's the rule. So here, if you see carefully, we can write the next term by adding the previous term. Just follow the pattern. So 1 plus 1 gives you 2, 1 plus 2 gives you 3, 2 plus 1 gives you 3, 1 plus 3 gives you 4, 3 plus 3 gives you 6, 3 plus 1 gives you 4. So you can calculate any row of the Pascal triangle using this pattern. So if you keep on adding, the next row is going to have the following binomial coefficients. So that is your row of the Pascal triangle. Now we are going to solve some questions from end of term coverage. So here this is learning objective 23. These questions that you see on the slide are taken from the exam coverage that is come for our grade 11 advanced. And here the learning objective is that we are going to use the binomial theorem to expand the powers of binomials. Now this part is a question on part 3. So it is free response question, means you need to show the steps. Okay, I've already provided in pink the final answer, so you can check your answers. We are going to try some questions here. So we'll do question 1 from here and question 15 from here. Let's solve it on the next slide. So the first question that we are solving from the end of term coverage is from learning objective 23, and we are covering examples 1, 2, 3 here. So let's do question 1. So here we need to expand the binomial using the binomial theorem. The two terms are C and D. They are added and they are raised to power 5. So we have to expand them one by one. So first we take the first term and expand it in this way. So we begin with the maximum power for the first term, and the second term is raised to the power 0. We will also use the binomial theorem. So we are going to leave some space for the coefficients of binomial. So first I'm writing the term. So next term would decrease the power of C by 1. So it will become 4 and increase the power of the second term. Then next term will have C to the power 3, D to the power 2. Make sure at each time the sum of the power is 5. Next term is going to have C2, D3, C1, D4, C0, D5, last term. Now their coefficients will be given by 5C0, 5C1, 5C2, 5C3, 5C4 and 5C5. Now we are going to just put the addition symbol. So remember, you can calculate these binomial coefficients, which I'm written using the combination formula. So 5C0, if you calculate, it's going to be 5 factorial over 0 factorial over 5 minus 0 factorial. So let me just write here quickly in case you have forgotten the combination formula that I'm using for the binomial coefficients. So it is NCR equal to n factorial over r factorial over n minus r factorial. Now in your exam, just to save time, you may use your calculator and directly calculate the binomial coefficients using combination formula. You need not expand them like I'm doing. You may just save your time by using the calculator. So here these coefficients will be 1. We have calculated these coefficients. Now we can similarly use 5C1. So this is going to be 5 factorial over 1 factorial over 4 factorial, which is going to be 5. Similarly, 5C4 is going to be the same value, 5 factorial, 4 factorial over 1 factorial. So this is going to be 5, and I hope you can see the symmetry between the coefficients. They will come, equal to each other. There is a symmetry, as you can see. 5C0 is also 1. 5C5 is also 1. These two coefficients are symmetric. Similarly, 5C0, 5C4 are symmetric, And as you would see in the next few minutes, that these two are also symmetric. So 5 factorial over 2 factorial over 3 factorial. This is 5 factorial over 3 factorial over 2 factorial. So this is going to be 5 multiplied with 4 over 2, which is going to be 5 multiplied with 2, which is going to be 10. So these two values are also equal. So here it is 10, here it is 10. Now we can put in place of these combinations the numbers that we have got. So in the next step, I will write the final answer here. 5c0 reduces to 1. So this is gone, this is gone. D to the power 0, remember any variable raised to the power 0 is 1. So this and this term becomes 1. So what we are left with, the first term C5, the last term D5. Next term 5C1 is going to be 5, 5C4D plus next term 5C2 is going to be 10, 10C3D square. Next term 5C3 is also 10, so it's 10C2D3. Next term 5C4 is also 5, 5CD4, and finally the last term D5. So this is your final answer. So this is how you expand the binomial which was given in the question, C plus D to the power 5, using the binomial theorem and using the combination formula. Let's solve from the same end of average. Learning objective 23, examples 1 to 3, another question. So here I'm taking question number 6, which is y minus 4z to the power 4. Okay, again we are going to use binomial theorem, so I'm going to expand it using that. So first I write the terms. So the first term is y. Now I may just convert this into this form, y plus minus 4z to the power 4. Why I do this? So that there is a plus sign and I can write each term in a similar manner. So the first term, as you know, y will have the maximum power, n is 4 here. The next term, minus 4z, is going to be 0. Then I write y to the power 3, power gets reduced, and for the second term it starts increasing. Next term is going to be y to the power 2, it starts reducing, and minus 4z, it starts increasing. Next term, y becomes power 1, minus 4z becomes 3. Next term, y becomes 0, and minus 4z gets the maximum power. Now it's time to write the binomial coefficient, so I will go to the combination formula. N, remember, is 4 here. So 4C0 will be the first coefficient, 4C1, 4C2, 4C3, and 4C4. By now you are proficient in using the combination formula, so you know 4C0 and 4C4 is going to be 1, so I will directly write it 1, and here the power 0 and power 0 will be 1. So this term goes, we are just left with y to the power 4 here. The last term is going to be, now there is a negative sign but even power. So remember, when you have negative sign and even power, the result is positive. However, if you have a negative power, negative and odd power, it is going to be negative. So just keep that in mind. So this last term is going to come minus 4 to the power 4 z to the power 4. Okay, I have just written the last term. It's going to be positive. Let's write the next term. So 4c1 is going to be 4 factorial over 1 factorial over 3 factorial y to the power 3, and this is negative sign. The power is odd, so the result is going to be negative. Then 4c2 is going to be 4 factorial, 2 factorial, 2 factorial, y to the power 2. Here the power is even, so it will give a positive result. So minus 4 square z2. Okay. And then writing this term also, which is there. So I will directly now write 4 because I know this thing. This combination formula is going to simplify and give you. So I'm directly writing 4 here now. and then we write this term, which is y and minus 4 to the power 3, and then z cube. Okay, not to forget that. So let's simplify our answer. So y to the power 4 is the first term. Multiply this thing, open the brackets, so it will come out to be positive 256 z to the power 4. When you expand this value, that means minus 4 is multiplied 4 times to give you 256. Okay, so this is the last term. It is also positive. Now here, because of the negative sign, I will now change, and this becomes 4 multiplied with 4, so it's going to be 16 with a negative sign, and y has power 3, z has power 1. Okay, open this thing, open the factorial, simplify, and this term will come out to be on multiplication, this multiplied with 16 will give you 96 with a plus sign, because this has power even. Okay, and y square. Similarly, you simplify this thing. Now for this term, there is a negative sign and power is odd, so the result is going to be negative. 4 will be multiplied 4 times, so it is going to still give you 256 y and z cube. Okay, so now we have written all the terms 1, 2, 3, 4, 5. So the final answer for this question is going to be, let me change color and write y to the power 4 first term minus 16 y cube z plus 96 y square z square minus 256 y z cube plus 256 z. So this is how we use the binomial theorem for expanding the binomial and writing the coefficients using combination formula. Now you can check for examples 1 to 3 your answers. I have provided the answers here in pink. We have already finished 2 parts from here, question 1 and question 6. Now we are going to try some questions from here. So the first question we are going to do is question 15, and the next one that we'll do is question 19. Let's see in the next slide how we can solve examples 1 to 3 and expand using binomial theorem. Okay, so let's continue our end of term expansion. So here now we are on the same learning objective 23. We are trying out question number 15. Remember, this is a 6 to 7 mark question. So you need to show all the steps. It's going to be free response. You have to solve it in your pen and paper. So don't miss any step. Let's start with the first question. So a minus b to the power 6. The first step is we are going to write it as a positive binomial. So a plus minus b raised to the power 6. So what is the first term? A. What is the second term? Minus b. What is the value of n? 6 here. So we are going to now expand using binomial theorem. So I write the first term a to the power 6 minus b to the power 0. The next term, the power of a gets reduced, 5 to the power a to the power 5 minus b power gets increased 1. The next term, a becomes 4 raised to the power 4 minus b becomes power 2. Next we have a to the power 3 minus b to the power 3. Make sure that at each step the sum of the power is always the value of n, which is 6 here. If you are getting something else, means you have done some mistake. So do correct it. So a2 minus b to the power 4. Next term, a1 minus b to the power 5. And finally the last term, a0 minus b to the power 6. So these are the terms. Now we will write the binomial coefficients, and it's 6 here, so we begin with 6c0, 6c1, 6c2, 6c3, 6c4, 6c5, and 6c6. So these are your binomial coefficients. Now we will use the combination formula. So as you saw in the last slide, the combination formula NCR is given by n factorial over r factorial n minus r factorial. Again, I would like to remind you, I'm doing this question without a calculator. However, you can try using calculator for getting your binomial coefficients. Means these combination formula, you can directly get the values from your calculator just to save time in your exam. So 6C0, we use the binomial formula and the combination rule. It's going to be this value, which is 1. Similarly, 6C6 is the same value, as these are symmetric coefficients. Then 6C1 is going to be 6 factorial over 1 factorial, 5 factorial, so this is 6. Symmetric coefficient is 6C5, which is going to be 6 again. Then you have next one, 6C2, which is going to be equal to 6 factorial over 2 factorial, which is going to be 15. And the symmetric one to this will be 6C4, which is also 15. Finally, now I'm just doing it in a quick manner. 6C3 will be equal to 20. So have we got all coefficients? Let's check. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So everything is there. Now we just need to plug in the value. So in place of 6C0 and 6C6, we are going to put 1. In place of 6C1 and 6C5, we are going to put value 6. In place of 6C2 and 6C4, we will replace 15, and in place of 6C3, we are going to put 20. So let's go to the next slide and complete the question. Okay, so now I'm putting the values, replacing the binomial coefficients. So our final answer, a minus b to the power 6, will come out to be, so I replace 1, a to the power 6 minus b to the power 0. Then you have plus 6, a to the power 5 minus b to the power 1, plus 15, a to the power 4 minus b to the power 2, plus 20, a cube minus b to the power 3, plus 15, a square minus b to the power 4, plus 6, a to the power 1 minus b to the power 5, plus 1, a to the power 0 minus b to the power 6. Now the last step for the question. Remember, as we did in the last question, this value and this value are going to come equal to 1. So the first term will be a to the power 6 and the last term will be b to the power 6. Let's write it. So first and last is done. Now, whenever there is a negative sign and an odd power like this, and like this, the result will be negative. So the next term is going to be negative here, and similarly the term before this is going to be negative. So this is going to be 6 a to the power 5 b. Next term 15. Now this is going to be positive because the power is even, so the minus sign doesn't make any difference. So 15 a to the power 4 b square. Again, here the power is odd, so the negative sign will give you negative 20 a cube b cube. Power is even, it will give me positive, plus 15 a square b4. Again, power is odd, so it will give you negative 6 ab to the power 5 plus the last term. So this is the final answer for this question using binomial theorem. So one question using Pascal's triangle also. So I'm continuing on question 19. The question is 2a plus 4b to the power 4. So if you observe here, n is 4. So the binomial coefficients either you can get with the combination formula like we saw in the last slide, or you can get it from the Pascal's triangle. So the fourth row of Pascal's triangle will give you the correct answer. So we will write the coefficients in the fourth row. They are 1, 4, 6, 4, and 1. That means these are going to be our coefficients. Now let's look at the term. The first term is 2a, the second term is 4b. So when I'm expanding this binomial using the binomial theorem, I have to take this into consideration. So the first term will have 2a to the power 4, 4b to the power 0. What is the coefficient? 1. So we will replace it in some time. Next term is going to be 2a, power reduces. For 4b it increases. Next term 2a square, 4b square, and make sure at each step the sum is always 4. So 2a1 4b cube plus 2a0 4b4. Now I will fill in the coefficients. So the first coefficient is 1, the next is 4, the next is 6, the next is 4, next is 1. Now let's expand it, open the brackets, multiply. So this is 2 to the power 4. A to the power 4, this thing becomes 1, this thing also becomes 1. So this is what is left, plus 4 multiplied with, this is 2 to the power 3. So that is going to be 8 in the next step, a cube, and then you also have a 4 to be multiplied along with b, plus 6 times 2 to the power 2, that is 4, a square, 4 to the power 2, that is 16, b square, plus next term 4 multiplied with 2, that's 8a, multiplied with 4 cube, b cube. So you may use your calculators just to simplify your calculation and save time. The last term here is 4 to the power 4, b to the power 4. So if you simplify, in the next step 2 to the power 4 comes 16, a4, multiply all these numbers, 4 with 8 with 4, so it comes 128. We are left with a cube b, plus multiply all the numbers here, it will come 384, a square b square, multiply 8 with 64, it will come out to be 512 ab cube, and finally the last term 256 b to the power 4. So this is the final answer for question 19. Please note we have done this question using Pascal's triangle for the binomial coefficients. However, you may have used the binomial theorem also. If in your exam it says use binomial theorem, do that. If it says use Pascal triangle, do that. If it doesn't mention which method to use, you may use any one which you find more easy and saves time. Both methods will give you the same answer. This is your answer for this question. In your end of term exam coverage, there is one more question in part B using the binomial theorem to expand the powers of binomial, as you see on this slide. That is example 4, question 23 to 28. Since this video has become pretty long, I'm going to be covering this question in my next video, so stay glued to the channel. Thank you for watching this video. I hope you found it useful, and if you did, please make sure to like, share and subscribe to the channel for more math revision videos. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye students.